Okay, let's take a look at this statement. It says, I can determine that velocity may be positive or negative depending upon the direction of motion and reference point. And I can recognize that velocity is not always equal to the speed. Let's take a look at an example here. Let's say that on the far side of the room you have the dinner table. That's supposed to be my dinner table. A little flower in the middle of the table. Isn't it pretty? Okay, so this is going to be our reference point, which is the table. Okay, and let's say you just walked in the door. You are right over here. Here's you, and you're super duper hungry. And let's say that you are moving toward the dinner table at a speed of 5 feet per second. Okay? And you're moving again toward the table. So maybe to make this an exact velocity, we would say toward the table. That way we have a direction, magnitude, and direction on this. Okay, so you're moving at 5 feet per second toward the table. Now let's say for a second that you're at the table. You made it. You're eating. And now you want to move away from the table. And you move in this direction. You're finished with dinner. In this case, even if you move at the same speed of 5 feet per second, you're moving away from the table. So what we could do is make this a negative 5 feet per second away from the table. Okay? So this would be an example of when velocity can be positive or negative depending upon the direction of motion or reference point. Just like it is here. In this situation, you had the speed that was the same, but the velocity is different because in one case you're moving toward the reference point, and in one case you're moving away from the reference point. The second part of this says, I can recognize the velocity is not always equal to the speed. And this would be, again, a perfect example. Okay? So yes, the speeds are the same in both of these cases. However, the fact that this is negative and this is positive makes them different. There you go.